Assalamualaikum. My name is ILYANA binti ABDUL, metric number DE220101. We are from Section 2, Group 5. We will be presenting our project with the title of PV System Design of Medium-Sized Clothing Manufacturing Facility with Moderate Machinery Load. A bit introduction about our project is that the manufacturing sector is a significant consumer of energy, and facilities like this often rely heavily on grid electricity. So this reliance comes with challenge, including high operational costs and environment concern due to the carbon emission from non-renewable energy sources. To address this challenge, renewable energy, particularly solar energy, has emerged as a viable solution. Photovoltaic systems are an excellent way to harness solar power and reduce dependence on conventional electricity. Specifically, a GCPV system not only generates clean energy on site, but also maintains grid connectivity to ensure a reliable power supply. So our project focused on designing a GCPV system tailored to the energy needs of this manufacturing facility. We will use both manual calculation and advanced simulation through PVC software to create an efficient and cost-efficient design. So through this project, we aim to demonstrate or support 50% of total energy consumption and reach 80% of performance ratio used to evaluate the efficiency and overall performance of PV system. For the problem statement, medium-sized manufacturing facility face significant challenge due to their reliance on green electricity, high energy costs, and the environmental impact on fossil fuel-based power generation are major concern. Additionally, the unpredictable nature of energy prices creates financial instability for these facilities. So, to address this challenge, a sustainable energy solution is needed, one that can reduce operational costs, lower the carbon emission, and ensure reliable energy supply. A grid-connected photovoltaic system offers a practical solution, but its success depends on careful design and integration to meet the specific energy demands of the facility. So this project aims to tackle this challenge through a tailored GCPV system design. So the objective for this project is to determine the optimal PV system configuration through manual design and calculation and PVC software simulation. The second one is to support 50% of the total energy consumption of a medium-sized clothing manufacturing facility with a moderate load on its machinery. The third one is to reach 80% of the performance ratio for manufacturing facility, and the last one is to quantify the environmental benefits, including carbon dioxide emissions reduction of the system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Ahmad KHAIRI. So I will present about the methodology of the project. So first is a project site location. The site project is in Kampung Barat Dutong, Malaysia. So the postcode of the site is 44,600 Batu Pahat, and the latitude of the site is 1.86 knots, and longitude is 103.08 east, and the altitude of the site project is 16 meter from the sea level, and the peaks and hours is 4.5 hours per day. So for the sizing of PV array, have 4 factors considered, is which is choose the PV module. Second is architecture constraint, and third factor is energy constraint, and the last factor is maximum demand constraint. So first factor is choose the PV module. So in choose the PV module have 5 factors, which is PV module rating, PV module efficiency, temperature fluctuation of PV module, dimension of PV module, and the potential yield. So and another factor is architecture constraint, have 2 orientation, which is first landscape orientation, first portrait orientation, and so which one the orientation that produce more energy. So the third factor of the choosing the PV array is the energy constraint. So we use the equation so that The project aims to reduce the total energy consumption by 50% of the total usage, which is 120,000 kilowatt hours. So the normalized energy consumption we calculate is 144,000 kilowatt hour. So amount of the energy supplied by the GCPV is 72,000 kilowatt hour, and the total power rate at STC is 198.3 kilowatt. So the last factor is maximum demand constraint. So for the commercial small industrial, PV system installed should be 75% of the maximum demand of the consumer. For the characteristic of PV module and inverter, so first we through the PV module characteristic. We use a brand from Zico Solar. The model is GKM 600 N666 HL4M BDV. So the power max of PV module at STC is 600 watt power. The number of modules we use is 8 to 8 modules, and total Pmax of the PV module is 496,800 watt power. So voltage at Pmax is 673 volt, and the current of Pmax is 684 amp. So for the characteristic of inverter, we use Huawei technology. The model is Sun 200 100 KTL and 1. So for the rating of the inverter is 100 kilowatt AC, and we use 4 inverter, and the total power of the inverter is 400 kilowatt AC. So that DC AC, for the DC AC ratio is 1.24. So that current at Pmax is 684 amp. So that's all.
Assalamualaikum, my name is SHAHRIZAL. So now I present to you our result from the PVC simulation. Okay, first is system overview. And after picking the module and inverter type, we run the simulation. It came out as we need 828 of PV module, which is consists of 600 watt power each. And after combine it, we get 497 kilowatt power. And the configuration for the PV module is 46 string with 80 module per string. Okay, so for the inverter we use inverter Huawei Sun 2100 KTL M1, and we need 4 units of that, and total inverter per capacity is 400 kilowatt AC, and the ratio between it is 1.24, which is ideal. And the array, we set it up to tilt angle, which is 10 degree, and the azimuth is facing south. Okay, so next is single line diagram. So this is the single line diagram produced by the PVCs. As you can see, it shows 18 times 11 string into 2 inverter. And another one is 18 times 12 string into 2 inverter, which is consists of 4 inverter total. And if we calculate the string times the 18 times 2, we get the exact number of PV module needs, which is 828. All of it pointing into injection point. Okay, so next is energy production and performance. As you can see, this is the table that produced by the PVCs. It is a summary for the energy production throughout the year. And the highest one will be in March, which is 66,609 energy injected into grid. And the lowest one will be the December, which is 46,884 kilowatt hour injected into the grid. Okay. Okay, for the performance, as you can see, this is the graph that produced by PVCs. And for the performance ratio, we get 85.8%, which is beyond what the lowest that we want, which is 80%. So this indicates that our system performance ratio is good. Okay, lastly is system losses. As you can see, this is the diagram loss produced by PVCs. So it consists of multiple type of losses. And the highest one will be the temperature losses, which is contribute 7.46%. And next is module mismatch, which is 2% loss due to variability in the performance of individual PV module within the array, and many other type of losses. And despite all these losses, we're still able to achieve the good performance ratio, which is 85%, and the efficiency of the system also good. So that's it for the result of this project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Adam Ashraf Saleh and my matrix number is DE220204. And now I would like to continue on the environmental and economic impact of this project. So for the first one is for the CO2 emission reduction. So the system avoid approximately 446.95 tons of CO2 emission annually by replacing the grid electricity with the solar energy. So over a 25-year lifespan, the total CO2 reduction is estimated to be at 11,173 tons, thus significantly contributing to the sustainability. Okay, for the second point is the alignment with the renewable energy goals. So the system supports the Malaysia's renewable energy targets and global climate action initiative, demonstrates the feasibility of renewable energy in reducing the industrial carbon footprints. And lastly, for the third point is the positive environmental contribution. It promotes the adoption of clean energy solution, reduce the reliances on fossil fuels, and also helping to mitigate the impacts of climate change. And lastly, for the conclusion. So the project successfully designed a grid-connected PV system for a medium-sized manufacturing facilities that cover 50% of its energy demand. And the system also achieved a high performance ratio of 85.85%, thus exceeding the first target of 80%. The third point is the system demonstrate a significant environmental benefits by reducing 446.95 ton of CO2 emission annually and over 11,170 ton over 25 years. The system, comprising of 828 PV modules and 4 inverters, showcase a efficient and reliable energy production. Challenges such as temperature-related losses were effectively mitigated through careful design and component selection. The project highlights the feasibility of GCPV system in industrial application, contributing to Malaysia's renewable energy goals and global climate initiative. That's all from us. Thank you.